Welcome to Rges Algebra 2. This is lesson 1.2 called the field axioms. Now, axioms are going to be basic properties that, at least for now, we're going to accept without proof. Many of them will seem somewhat obvious to us, but we will not do any formal proving of them. Now, these axioms are going to be applied to two mathematical operations, addition and multiplication. The first one is closure, and we're talking about the set of real numbers. Now, we've already talked about what the set of real numbers are. So go back to 1.1 and review that if you need to. What we're saying in the closure property is that both addition and multiplication are closed to the real number line if we begin with real numbers. So remember, the real numbers can all be placed somewhere along the real number line. If I take anything that's already on, any point, any number, value, that's already on the real number system, whatever it is, whether it be a rational number, an irrational number, whether it be an integer, it doesn't matter. If I take any two values and I add them together, my answer will also be on the real number line. That's closure. It does not jump off this line. It does not exceed, doesn't turn into an imaginary number or a complex number. The same is true for multiplication. If I take any values on the real number line and I multiply them together, my answer will also be on the real number line. So that's what closure is all about. Commutative has to do with changing the order. This simply means that if you take any two values, let's say 3 plus 4, I could also reverse the order. First add the 4, take the 4, and then add 3 to it, and I will come up with the same answer. So I am free to do addition in any order and of the two values, and the answer comes out the same. So I'm changing my order. What about multiplication? Is 3 times 4 the same as 4 times 3? And the answer is yes. So multiplication also obeys the property or the rule of, I should say the commutative property also applies to multiplication. So notice we're changing the order. We put the 3 first, then the 4, then the 4 first, then the 3. Okay, same with multiplication. What is associative property? Associative property, you do not change the order, but you change the way you group it. So let's say we have 3 plus 4 plus 5. Does that equal, if I group it this way, does that equal the same as 3 plus 4 plus 5? Notice I'm adding, so this is for addition. We're talking about the associative property of addition. I'm trying to get you used to the vocabulary here. Well, let's look at this. 4 plus 5 is 9, plus 3 more equals 12. 3 plus 4 is 7, plus 5 more. This equals 12, and it doesn't matter which order I associate these in. The answer comes out 12 both times. Now, for multiplication, you could probably already anticipate what I'm going to do here. I'm going to have 3, that doesn't look like a 3, 3, 4, 5. I'm going to first multiply the second 2, and then multiply it by the first. Remember, if I write a number right next to a parenthesis sign, this implies the operation multiplication. Does that equal 3 times 4 times 5? Again, with the implied multiplication right there. Well, let's see. 4 times 5 is 20. 20 times 3 is 60. 3 times 4 is 12. 12 times 5 is 60. And so the associative property holds for both addition and multiplication. Identity. Identity has to do with not changing a value, wanting to add something to it for addition, identity property for addition. Let's say I have a 7. I want to add some value to it such that when I'm finished, I will have a 7 also. It will be identical. What can I add to 7 to get 7? And the answer, of course, is 0. We call 0 the identity value for addition. What about multiplication? What if I have 7 and I want to multiply it by some value to get an answer of 7 when I'm done? What would I have to multiply 7 by to get 7? And the answer is 1. So we notice that 0 is a very special value when I think of addition, and 1 is a very special value when I think about multiplication. Okay. Now, that relates to inverse. Okay. The inverse property for addition says, what must I add to 7 to get 0, to get the additive identity? Now, we could also think about it as undoing. What can I add to 7 to undo that number? Okay. Or here would be another way to say it. What if I have a value, let's say 3, and I'm adding 7 to it? How do I undo that addition of 7? Well, I would add a negative 7. We call this the additive inverse, the negative of the original value. Okay. Now, I could go on and explain a little more, but I think I'll wait on that. Okay, what do I need to multiply? Seven by to get the multiplicative identity. In other words, how would I undo multiplying by 7? Well, I would multiply by 1/7. Why is that? Because that would be 7. This would be, if I'm multiplying 7 by 1/7, remember, this would go with the numerator, and that gives you 7 over 7, and that gives you 1. If you recall that. So this would be the reciprocal. The reciprocal is the inverse operation of multiplication. The negative, adding a negative, is the inverse operation of addition. I want to show one more thing regarding that. Let's go down below here. Let's say I had a number. Let's say you had the value x. And I add 7 to it. And now I want to undo that so that when I'm finished, I have x. How would I undo it? I would then subtract 7 or add a negative 7. Right? And this operation and this operation, let me think of that as adding I want to think in terms of addition, so I'll say add a negative 7. These undo each other. Let's say I'm multiplying by 7. What would I also want to multiply by so that when I'm finished I get x? Well, I would want to multiply by the reciprocal. So when I multiply by 7 and then multiply by its reciprocal, I've done the operation, and I finish with what I started with. And that's probably, certainly in a practical way, that's obvious to you because that's the nature, the essence of what we do when we solve equations, and you've been doing that all through Algebra 1. Now let's talk about one more idea, the distributive property. The distributive property, I've put it in further because it's not associated with either multiplication or addition. Instead, it's associated with both those operations together. So recall something like this, where I have a multiplication here and an addition there. I could solve that this way by order of operations, or I could distribute it, making it two multiplication problems. For instance, that would be 3 times 4 plus, looking at that operation, 3 times 2. Does that work? Well, on the left-hand side, we would have 3 times 6, which is 18. On the right-hand side, I would have 12 plus 6, which is 18. And yes, it's the same on the left and the right. And this is probably almost all review for you, but what you are expected to be able to do is give an example for each of these properties and also recognize them when you see them being done. They do form the foundation of much of even arithmetic and definitely of algebra. They're very important properties, so learn them well.